wiring 101, right? What fuse, what toggle, what relay, what gauge wire, all that's based on figuring out what kind of load you're trying to operate. For instance, a fan, electric fan. Electric fans take anywhere around 17 to 20 amps to run, but then there's a startup amperage which can push as high as 28, 29, right? So that's why we usually run a 30 amp fuse. So the first thing you want to do is figure out what your load is going to be, and then you can determine how far away that load is from its power source, and then you can calculate what wire gauge you need. There's a million charts online to tell you the distance you're going to run your wire and the amount of load that you're going to transfer through that wire, and it'll tell you what gauge wire to use. So I'm not going to go into that. That's something you can look up on the internet. Then the next thing to understand is how you're going to switch that device on and off. Is it going to be triggered by an ECU, or is it going to be triggered by you simply flicking a toggle switch or hitting a button? So the normal thought is you got to think of a flow, right? So from the battery through the switch, out of the switch to the load. Now you have to think, well, can the switch hold the amount of amperage you need? So a fan has a startup of 30 amps potentially, and operating around 17 to 20 amps. And if you've got a toggle switch that can only hold 10 amps, well, then that's not going to work, right? So you either get a toggle switch that can hold the amperage, which can get large, you get this giant 30 amp switch, or you can use a relay. What a relay is just a secondary switch that's a high amperage switch. So you can keep that closer to the battery, closer to the fan, so that the distance you're running the wire is shorter, so you can use a smaller gauge wire, and then you just use a small toggle switch that only needs to hold a few amps to trigger the relay, and then that will then turn the device on. So it's just a secondary switch. So now that you know what fuse, wire gauge, relay to use, the relay in essence is just a mechanical connection that's an electromagnet. By supplying power or ground, however you want to trigger it, you connect a circuit inside, and it's a physical connection that spring loads and goes back and forth. That can fatigue over time, right? So like a coat hanger, you can only bend it so many times before it breaks. So it's something that can fail, or it's something that has a potential to fail. It also has potential to fuse itself together, to almost weld itself together. So it's good, and it's used in all over the world to control things. But why I'm telling you this is because we're moving forward with the automotive world, and things are becoming solid state. And then having a fuse and a relay is something that's going to be of the past. It's like carburetors and fuel injection, right? Nobody has a carburetor anymore. So a lot of cars, most cars, when they come out, you're not going to have fuses and relays anymore. It's just going to be a thing of the past. So when people ask, do I need a relay, do I not need a relay? It all depends on what you're running and how far away that device is from the battery in your switch. So the next step up, once you've figured out how to wire in a single item, a light bar, fan, whatever, you can start making your own fuse boxes. Very simple, right? You have a fuse box that has fuses in it, and you have relays in it, and you have toggles that trigger these relays to click and then send power down your line to whatever you're trying to power up. This is a super simple way to do things. You have a main hot coming in that would feed everything and send it out. This is something that's very common in simple hot rods, simple off-road cars, things that just need to be very simple and inexpensive. You can put this whole harness together yourself with a little bit of time for a couple $100, and you'd be good to go. So this is a good example of how to use relays to get multiple functions taken care of. We put these together for vehicles, hot rods that need to have a left turn, right turn, but they have a single bulb running light. So when you click one toggle to turn on your running lights, that triggers this relay. But then when you do a left turn, you've got to have the right tail light stay solid and the left tail light flash. So that's when we have this type of setup using 3 different relays to accomplish that goal and how we wire it. It's a little bit more complex wiring. I won't go into that right now, but it's just an example of how you can use multiple relays to accomplish complex tasks in your car. Another good example would be when you turn on your high beams and your fogs at the same time. You've got to have, when you turn your fogs on, the high beams have to shut off automatically. You could do that with multiple relays. So now that you've seen a few minutes of how relays work and how to pick wire size and how fuses are chosen, now you're ready to go ahead and throw a Gen 5 LT1 into a Defender 110, because it's all the same stuff, except for we did it just a little bit different in that we used Race Pack and the Race Pack Smart Wire. And it's essentially a mini ECU. It's like a body control module in a modern car, and it uses all solid state so that we don't have to use relays or fuses. So now that you know how to use them, we don't like to use them, only when we have to. Now we can program it. It's all logic based. So if we do have a right turn, left turn, or we have a high beam fog situation, we just simply program it in and tell it what we want it to do. If this light is on, turn that light off. Or if this light is flashing, keep that light on. It's all programmable. Makes it way easier. So in this car, we've integrated a lot of systems. We have the Gen 5 LT1 ECU, and then the small harness that came from the engine manufacturer. We didn't want to change, just strictly for the customer's request to leave everything from the engine manufacturer untouched. So all we did was hook their stuff up. So there are 4 fuses and 4 relays for that system. The rest of the vehicle is operated off of the Race Pack Smart Wire. So this is basically our body control module, and we have it programmed to control everything else in the car. Lights, windshield wipers, horns, everything, and it's all logic based and all programmable. This is the switch bank that you can also get from Race Pack. And this is where we have our ignition and then our start and several other features. We're going to remotely mount in different places. We've also been able to utilize stock switches, horn switches, headlight switches, turn signals. We've been able to use the stock switching mechanism and just tell the smart wire what to do when the person commands this. It's super simple, makes everything a ground trigger if you want it to be, which just makes it very basic. But then we'll also have a few other switches throughout the car on this console when it's done. This looks kind of chaotic right now down here. It's because it's not a finished product. It's a work in process, and it will actually, we'll go through and clean and tidy everything up after all of the function tests and after everything works. Seat heater switches, all that stuff will be remotely mounted. Basically, imagine doing this system where you've got, 100 different circuits, but you're having to do it and wire a relay for every single one and a fuse for every single one. It can get really tedious and really expensive. So for the cost of buying a smart wire or an equivalent body control module, the amount of time you save building the fuse boxes that you're going to need, it's almost a wash, and this is a way better way to do it. So on the smart wire, each pin, when you get the instructions with it, it's going to have a pinout location for you, and you're going to know whether it's an input or an output on the smart wire. So it's important that you get those right. I know a lot of times it seems overwhelming. A lot of these connections that we've made, these connectors here on the smart wire, when you buy this kit, it's going to come with plugs and it's going to come with pins. And it's just very simply going to tell you which output and which input to use for what you want to control. You take your wire, you crimp it, you shove the pin in, you lock it down, it's good to go, okay? It's super simple. It's very, very simple. These connectors here we use, these are Canon plugs. We use these as a bulkhead connector. Anytime a wire is going to pass through somewhere, we like to use this. So this would be mounted to the bulkhead. The wires go out the bottom of the car to where we need them to go. And then the other wires come in, it makes a connection. All it's doing is making a connection. If you're not comfortable with that, or it's not in the budget, then just run the wires through a hole and put a grommet there, and then maybe seal it with some weather stripping glue or some silicone and send it off to where it needs to go. On these Canon plugs, it's strictly up to you, the designer, what you want to do. You just have to buy the right size plugs to hold the correct gauge wire. That's the biggest thing to look out for in that. But it's very simple. This is just one way to do it. It's wiring. There's There's lots of ways to route wires. It just depends on how in depth you want to go and how big your budget is. To kind of summarize, I know that there's a lot of information on the internet about what gauge, what fuse, and how to wire a relay, specifically how to wire a relay. But what I wanted to go over was just basically that wiring in general is not difficult. It's not rocket science. It's getting power from point A to point B. It's like turning a faucet on and you want to get water across your yard, you hook a hose up and you get it to where you need to go. That's all we're trying to do. Yes, you need to pick the right equipment and the right wire size. You can research that, it's super simple. But just to don't be afraid to jump in and do some wiring projects. As long as you pay attention and make good connections, you're going to have something that works, and it's going to work just fine. All right, so that pretty much wraps up the wiring tech tip. If you guys have any comments or questions, please comment on the video and I'll respond to it. Or if it's something that we get a lot of comments on, we'll make a more in-depth focused video on just that specific subject. Thanks. See you next time.